Okay. Okay, we're live. And I do have to kind of speed through this one, if that's okay.
Yeah, that's cool.
I just have something going on tonight. We did most of them, but there's a few at the end I didn't get.
Okay, we'll rock and roll then. Okay.
One has it up.
Okay.
All right, let's go right into 3. So it's asking us, let's see. So it gives us the z-score, and we basically just have to shade to the right of the positive and the left of the negative. But, right?
Yep.
We got 0.175.
Right.
So 0.175, right?
Yeah.
Okay. Okay.
Or the following will have, which of the following will have smaller standard deviation if 9 observations are randomly drawn from the population? What do we need to know what they are?
I would think so.
Okay, I don't think it can be determined because we would need to know like the numbers in order to actually calculate it.
I think so.
And I always get for 5, I always get central limit theorem and law of large numbers. That's the one we had switched last time too. I think it's the central limit theorem.
I think it's the central limit theorem. I think, but I'm not definitive on that one.
Yeah. I was going back and forth between that and the law of large numbers.
Yeah, that's right.
Okay. Then for 6, we just have to find the z-score.
Okay.
Okay, I got 1.045.
That's what I got.
Okay, cool.
You get that, Frank?
1.045.
Yes. Mm-hmm.
Okay. Yep. Yeah.
Perfect. And then for 7, let me just make sure I have this right. You put in 1.054 for and then you shade above like the top portion on applet. I think
1.045. Is it 0.148?
Perfect. Yeah. Okay.
So 1.48 or just 148?
0.148. So what is the z-score corresponding to the sensor?
Okay.
We just add all those up and divide it by 5. I think.
Yeah. So adding all up and dividing by 5 gives you 160.
Okay. So it'd be the same. So it'd be the same to 1.045. Or is the sampling different?
I think it's a different. I looked that one up, trying to find like I got a different number. It's 2.338, but I'm gonna have to go back and see actually how I got it. I had to look up on the
So I think you're right. It's something different.
Yeah, so it's it has something to do with like the square root. I'm trying to find the actual like formula. Let me just look back through. Okay. Should have looked that up. So it's the same formula. You just take the square root of 160?
So you do the same thing. So you do like 160 minus the mean of 150.8.
Yeah.
And then you divide that by the standard deviation divided by the square root of n, or how many samples. So that'd be 5.
Yeah, so the square root of 5. Okay, that's exactly what I did.
And so did you get 2.337?
2.338 with rounding.
Yeah, let's see.
That might be 7 though. Hold on, I can see.
Yeah.
Yeah, 7.
Okay.
Okay, and this next one, you just put that z-score in to the applet.
Mm-hmm.
And then you shade everything to the right.
So with rounding, is it 0.010?
So this one says round to the nearest 4 decimals.
Oh, okay.
So 0.0097. Is that what you guys got?
Yeah. 0.0097.
Yep. Suppose the GPA.
That approximately normal.
Yeah.
Yeah.
The mean of distribution. Is there a specific formula for that?
The mean of the distribution. And then do question. Okay, so it's so this one's using the square root.
Yeah, but you don't have a. It doesn't give us a sample. So usually you take the sample minus the mean.
Yeah.
So I'm not sure if you just do the mean. I'm not sure.
The mean of the distribution. Oh, we're supposed to use the one. Okay, so it's suppose the mean GPA of the BYU Idaho students is 3.5. Standard deviation is 0.7.
So would you take 35 divided by 0.7 divided by the square root of 81?
Yeah, that's what I would think.
So if you do that, unless I did it wrong, it gives you an answer of like 448. But I don't.
Oh, that's what
Yeah,
I
I don't know.
It just doesn't seem.
doesn't seem right though.
The mean. Oh. Mm, is it just 35?
Okay, let me read this again.
Or is it not 35? 3.5.
Mean of the distribution. Yeah, 3.5.
Let me try something. So 3.5 is the mean. I thought it was 35.
Yeah, 3.5. Okay, that's I think what I did wrong too.
So that gives you an answer of 44.87.
That makes a little more sense.
But I think it's just asking for the mean, because I know in some of the homework questions, it was some of the questions just asked for what the mean was.
That's true. So it'd be 44.9.
Yeah. Why do you need scissors?
For cutting my
44.9.
I need cutting
44.
around my homework.
Okay.
Okay. Try it.
Okay, so this one you're just gonna find the mean, subtract the mean, and then square root it.
It doesn't give us a sample size, does it? Or it gives us the n, but usually it gives you something, and then you have to subtract that from the mean.
Is that what we just found in 11, though? The sample means?
Maybe. Was that? See, that seems really high though compared to the mean. 44 compared to 3.5. Because it has to do with GPA. So you can't go over the 4.0.
Right.
I don't know. These ones are. I don't know. These are confusing to me.
Yeah.
Okay, I think I might have gotten it. So, does it make sense? Let me go back to the question here. Okay, so I took 81, which is the sample size, minus 44.9. That's 81 minus 44.9. And then you divide, so that's 36.1. And then you divide it by the mean GPA, which is 3.5, and you get 10.3. You take the square root of 10.3, you get 3.2. 3.21. That makes a little bit of sense to me.
So what did you do? So you took the 81 minus the 44.9.
Right. So 81 minus 44.9, and you get 31.6. Then you divide that by the mean GPA, which is 3.5. You get 10.3. You take the square root of 10.3, you get 3.21.
So I'm just curious, where did you get that formula from? Or
Well, I'm just I looked up how to find the standard deviation, and you just take you figure out the mean between all of the information, and then hold on, let me just pull it up. So you work out the means, the sample average, and then subtract the mean. Okay, found it. You subtract the mean and square the result. Okay, maybe I just put numbers together, but it made sense to me. Find the average, take the value, and subtract the mean. Square each of the differences, and then multiply it.
Getting stumped.
So
Like similar problems like it, but
On the
Is-
homework for this week, number 5 is very similar.
all right, I guess we can just come back to that one. Unless, do we need it for 13?
So have you guys done the homework for lesson 7?
not yet, no.
I haven't either, no. Should I pull it up?
Yeah, there's one similar to it. I'm just trying to. I did it, but I can't remember how I figured it out.
Mm-hmm. So number 5.
Yeah. Just can't remember how I did it.
Now, is 13... Oh, Okay, so in chapter 7 or lesson 7, it talks about a likeliness being well below the probability of something. And so like if we enter that 3.3 into the z-score
Okay.
and find and put that in the low side of the z-score. So if we were to get something less than 3.3, it would be 0.9995. Like there's a
I found how I did that one.
Number 5.
Yeah. So for the standard deviation of the sample of means, I took 113, which is the normal standard deviation, and then divided that by the square root of the sample size. And that in on number 5, the example or the sample size is 30, and that gives you an answer of 20.632.
Okay. Which
Let
is
me
the
check real
answer.
quick.
It is the answer.
Okay. So if that's the same question we're looking at, we would take 0.7 divided by the square root of 81.
Which is 9.
Mm-hmm. But
0.77.
yeah, so to the nearest 3, so 0.078.
Okay.
But like I said, I could be completely wrong.
I say let's do it because I don't know. I'm stuck.
We can try it. Yeah, I'm stuck on that one. So.
Okay, 0.078. Sounds good enough to me. And then what were you saying about 13, Frank?
So I don't know, maybe I'm way off.
Probably not.
But doesn't it in the chapter, it talks about like when a probability is fairly or well outside of the range of the applet, it then, oh, maybe I don't know what I'm talking about. Like if you go to the applet and if the z-score is 3.3, which is the GPA, the probability that it would be less than 3.3 would be 0.9995.
So do we have to find out the z-score for that?
Yeah, because I would find the z-score of it first, and then put the z-score into applet, and then shade the left side.
Yeah. Well, buddy. What are you eating? No, don't eat that anymore. Okay, Kobe. No, close that. Sorry, my son's getting into candy. No, close it. No. No. Lyric. Get Liam out of the fridge, please. Get Liam out of the fridge.
So from that, let me know if I'm doing this right. So you take the 3.3 minus the mean of 3.5,
Yeah.
which gives you a negative 0.2.
Yep.
And then you divide that by 0.7 and divided by the square root of 81.
That's what I thought, but then I was getting a weird number. But that
And
makes sense for a z-score.
And then for that z-score, I think it's 2.564.
Yeah.
And then plug that in.
And so it'd be 0.994.
So you just shade to the left one, right?
Oh, no, I did wrong. Sorry.
Yeah.
So 0.0052.
Yeah.
Yeah.
Like that.
So just 0.005, right?
Yeah.
Okay. And then it's just that same thing, but just shading to the right. Because it'd be greater than 3.3.
Yeah, but do we just shade? We shade the middle and the right?
Yeah.
Okay.
Why the middle?
Should be everything above that.
Oh, yeah. Okay, yeah, okay.
So I got 0.9948.
Yeah.
So 3, so
995, 0.995.
Yeah.
okay.
I'm not gonna lie, I'm a little lost on this one.
Yeah, so find the probability that a random sample of passengers will have a weight that is extreme or more extreme.
Kind of don't know what they're asking.
Anyway.
So do you take 177.6 minus the 185?
I guess so.
And then do the same thing, divide it by the standard deviation over the square root of 48.
I guess, yeah, that makes sense.
You can try it.
So it'd be negative 7.4.
Yes, it's 7.4, and then you have to divide that by the standard deviation divided by the square root of 48. I found something, but I have no idea if it's right. So once you get that, do that calculation, you get a z-score.
So for that, did you get negative 0.04?
Didn't.
You didn't?
For the z-score?
For the z-score, yeah.
Mm-mm. Not saying that I'm right, but I didn't get that one.
No, that's okay. So you got negative 7.4, and you're going to divide that by the standard deviation, which is
26.7. But then you have to divide the standard deviation by the square root of the sample size.
which is 48, and the square root is 6.928.
Mm-hmm.
Divide
26.7 divided by 6.928 gives you 3.54. So then you take 7.4, or the negative 7.4, divided by the 3.854. I think.
Okay, I see where you're getting that from. Okay.
And so I got a negative 1.92.
Negative 1.92 for your z-score.
Yeah. So then you plug that in, and then you'd shade the right and the left. You'd leave the middle blank, because it's asking for extremes that are above or below the mean.
So you're shading to the right and the left.
Mm-hmm.
So 0.549.
Yeah.
Okay.
I'll go ahead and submit this real quick. See how great we did.
Okay.
Yeah, this one was hard.
Yeah, this one was hard.
And just to clarify, this last one, it was 0.549.
Yeah.
Okay.
That's what we're guessing here.
Yeah, that's at this point.
Yeah.
All right, so we missed 2.
Okay, that's pretty good.
Yeah.
Which ones?
We missed, let me get back. Number 4.
What? Number 4?
Mm-hmm.
Okay. So it can be determined.
Then it has to be the distribution sample means is that the line.
So the sample means one.
Yeah.
Okay, I can submit the next one. What's the other one that we missed?
Other one is 5.
So it's the large, the law of large. Dang it. Okay. Wow, we got all the other ones right. That's awesome. Okay, I'm submitting.
That's surprising. You did good.
Okay, I still have that we missed 2. I have 15. I missed. What did you have on 15, Samuel? 0.549?
So you have to round it.
Oh, I rounded it wrong. Okay.
Okay, so what?
And then the other one I have, I probably just put it in wrong, is 11.
I can't remember. I just exited out of it, which I should have done.
Do you still have yours up?
Yeah, I still have mine up.
Okay, I'm gonna just go back because all the other ones, I must have just written the numbers down wrong. So.
Oh, there's one. Sorry, not making any sense.
Okay, so question 3. There's 0.175.
0.175. Okay.
And then 4. Did you get that wrong again, or?
No, that one was right.
Oh, okay.
It was the sample
So
means.
Sample means.
And
then next one's the law of large numbers.
Large numbers, and then 1.045.
What's this giant underscore?
And then
What is it
0.
again? Sorry.
The
What was 6?
6 is 1.045.
Okay.
And then 7 is 0.148. And then 8 is 2.337. And then 9 is 0.0097.
0 point, sorry.
0.0097. Then 10 is approximately normal. 11, 44.9.
So 11 is wrong. So sorry, I put that one, I put a different answer,
Oh, okay.
and that's one I got right. So that one's 3.5.
3.5.
Okay.
Okay. 3.5.
Which ones did you miss, Taylor?
I missed 11 and 15.
11, 15.
I think I just rounded 15 wrong.
Okay. And
So it's
it was
15.
12.
And then
What
12
one?
is
Yeah.
0.078.
0.078.
13.
0.005. And then 14 is 0.995. And then 15 is 0.549. Or is that wrong?
So it'd be 0.0
0.055.
0.055.
Okay, got it.
Gotcha. Okay.
So, do you want to submit yours, Frank? See if we.
Yep, I'll go for it. And I think that's, 100%. We're good.
Cool. Awesome, guys. We'll meet again on Monday.
And we have a quiz next week, too.
Okay, perfect.
Yes, I'm not sure how that works.
I'm not sure either. I'm sure there'll be an announcement posted or something.
Yeah.
Okay.
It's due on Wednesday, though. I think.
Okay.
I'm not
Okay.
sure. I was reading something.
Okay, sounds good. We'll talk on Monday.
Okay.
Cool.
Okay,
See you
bye.
guys.